Morning. Sit down. So, as our topic is periodic classification of elements. Okay, how the elements are arranged in periodic table in the long form of periodic table. This is long form of periodic table or modern periodic table. In previous classes, we learned about how the periodic table is classified into 7 periods and 18 columns or groups, and that 18 groups again classified as 16 IUPAC group, that is IA, second IA, third IA, like this. Last one is 0 group, that is inert gas, then hydrogen group, like this. Already you know. Today we will discuss how the periodic table is classified into blocks. What? Today's topic is blocks. There are 4 blocks. How many blocks? 4 blocks. First, S block. Second one is P block. Third one is D block, and fourth one is F block. So, the total periodic classification again consists of 4 blocks classification: S block, this one P block, this middle one D block, and last one is F block. You know, electronic configuration, when in chapter 2nd we are doing our electronic configuration. In that electronic configuration, there are 4 cells: S, P, D, and F. These are 4 cells: S, P, D, F. When electrons are arranged in these orbitals, this is called electronic configuration. Already you know, yes or no? So, now there is some similarity. SPDF electronic configuration, and in this SPDF block there is similar. In there we use SPDF, here it is also SPDF block. So, it is very common to say that if electronic configuration of elements and or last subcell is S, that is 1s, 2s, 3s, 4s, etc., that element belongs to S block. Okay, suppose one example. One example is calcium. What is atomic number of calcium? What is atomic number of calcium? 20. If you write electronic configuration of calcium, then obviously it will comes argon 18, then argon 18, then 4s2. Now, what is the outermost cell? What is the outermost cell? S. 4s or S. The outermost cell, or that is subcell orbital, is S. That means calcium belongs to which block? Which block? S block. Calcium is in S block. Okay, fine. Now, the S block elements are generally ionic. S block elements are generally ionic compound. S block are ionic because they generally lose electron due to their presence of S orbital. Generally, even they can form covalent bond next in our chemical bonding chapter, but generally they are ionic. Now, the first group is called alkali metal group, and second group is called alkaline earth metal group. First one, this one, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, H, Li, Na, K, Rb, Cs, Fr. Okay, these 7 elements are called alkali metal. Exception is hydrogen is not a metal, exception. So the group 1 is called alkali metal, group 2 is called alkaline earth metal. Both are called S block element, that is S block element. Okay, fine. Now come to P block. P block elements, in P block elements, last subshell end with P block. Last electron goes to P subshell. Last electron goes to P subshell. Electronic configuration, obviously, what happened? P126. Last electronic configuration will be NP126. That means, suppose if we consider electronic configuration of chlorine, example chlorine, number of chlorine is 17. What is the configuration? 1s, 2s, 2p, then 3s, 3p, 5. What is the last configuration? 3p. Last configuration end in 3p. That means chlorine belongs to P block element. This, which color it is? Suppose red. This is S block. Yellow one is P block. This blue, it is D block, and last below 2 groups are, that is F block. Now the compounds, these compounds form both ionic or covalent bond. Both ionic or covalent bond. Now comes to D block. D block elements are generally metals. D block elements are transition metal. Transition metal. Why these are called transition metal? If you consider these elements, their left side S block present and the right side P block present. So character also transit. Transit means transfer, means similarities. Character of these elements transit between S block and P block. S block contain last electron in S, P block contain last electron in P, and this is in D. These two groups transit, so it is called transition elements. Okay, these are metal. These compounds have variable oxidation state. Variable oxidation state. What is oxidation state? Oxidation state relates to valency, which we will study on later. Oxidation state or valency. One important thing is that D block, last electronic configuration is in D, that is 1, 2. How many? What is the maximum electron in D orbital? In D orbital, maximum electron is 10. So last electronic configuration is D. One example, suppose take any one element from this. Suppose manganese. What is the number of manganese? 25. Then electronic configuration will be argon 18, then 4s2 3D 5. So last configuration is in 3D. Okay, since last configuration is D, then manganese belongs to D blocks. Manganese Mn. This is D blocks. All of you clear? This is D block. Then what is the theory about lanthanide and actinide series? If you consider one important thing, look carefully. In S block there are how many groups? In S block there are how many groups? 2 groups. In P block there are how many groups? There are 6 groups. In D block there are how many groups? 10 groups. Total 18 groups. And our periodic table consists of 18 groups. Understand clearly? Our total periodic table consists of 18 groups, 7 periods and 4 blocks. Remember this one. Total periodic table consists of 18 groups, 7 periods and 4 blocks. Jyoti and you say what are the blocks? What are the blocks? Total S, P and D. If you consider total S, P and D, then it will become total 18 blocks, 18 groups. Now our periodic table total consists of 18 groups. Then what is about lanthanide and actinide series? What is about lanthanide and actinide series? Lanthanide and actinide series, that is F block, there is no separate group. It consists of lanthanum and actinum. Okay, so F block, that is F block, it consists of lanthanum and actinum. From lanthanum it is lanthanide series, and from actinum it is actinide series. So this is about classification of total periodic table in blocks. Now next topic is how size of element vary in the periodic table, that is atomic size. Atomic size. Now tell me, in periodic table there are 118 elements. First element is hydrogen and like this. In atomic number 13 there is zinc. There is a question, each size of the elements are same? Understand? If the size of all elements are same, that is radius, atomic radius, you know nucleus is in the center and electron moves around the nucleus. So what is the size of atom? It must be circular. Yes or no? What is the size of atom? Rectangle? No. What is the size of atom? Lopamudra. What is size of atom? That is spherical. Okay. Spherical. If size of atom is spherical, if we take a small type ball and we take a big type football, then obviously their size vary. This is small size, this is big size. Now Aditya, what happened? Now if we consider the size of element, are these are same? No. Why? Calcium have 20 electrons, zinc have 30 electrons, and other elements that this, like gold, it have 79 electrons. So according to electron, it must vary. Now consider one. Listen carefully. What is number of scandium? What is atomic number of scandium? 21. What is the electronic configuration in last orbital? In last orbital, that is 3d1. Good. Then consider last element, that is zinc. Zinc. What is the number of zinc? 30. What is the last configuration? Okay, good, fine. Now consider these two. Scandium atomic number 21, electronic configuration 3d1. Zinc atomic number 30, electronic configuration 3d10. Now consider these two one. 3d and 3d, that means same cell. Yes or no? Same cell. Suppose this is nucleus and this is the 1s, 2s, 3s, 4s, like that. Suppose this is the 3d cell or subcell. Okay, in this 3d subcell, for scandium there are how many electrons? For scandium, what is the number of electron? For scandium, that is 1 electron. And for zinc, how many electrons? 10 electrons. Now compare two atoms, this one scandium and this one zinc. In this scandium, in outermost orbit, there are 1 electron. There is 1 electron. And in case of zinc, there are 10 electrons. Which have more nuclear charge? Which have more nuclear charge? Obviously, zinc have more nuclear charge. If zinc have more nuclear charge, then the nuclear and electron force of attraction will be increased in the zinc. Yes or no? If force of attraction increases, then what happened? This is nucleus, this is cell. If force of attraction will increase, then cell will be squeezed down, means radius will be decreased. So scandium have greater size than zinc. It means, what is our conclusion? Our conclusion is atomic size decreases. Atomic size decreases from left to right in a group. So our conclusion is atomic size decrease from left to right in a group. Understand? Then compare in a group, that is top to bottom. Consider lithium. What is number of lithium? Atomic number of lithium 3. Configuration is last 1s2, 2s1, last one is 2s. Now consider potassium. Potassium. What is atomic number of potassium? Potassium atomic number is 19. What is electron configuration? In last subcell 1, 2, 3, 4. 4s 1. Yes or no? Lithium have electronic configuration 2s1 and potassium have electronic configuration 4s1. What is 2s, 4s, 3s? What are these? These are subcells or orbitals. Okay. So we conclude that when we move from top to bottom, then another cell is added. That means in lithium there are 1, 2 cells, and in potassium there are 1, 2, 3, 4 cells. Now compare lithium and potassium. In lithium there are 2 cells, 1, 2. That means size is like this. And in potassium there are 1, 2, 3, 4 cells. That means size is like that. So what is the conclusion? Atomic size increases from top to bottom, and that is in a group. So in a group, H, L, I, N, A, K, R, B, C, S, F, R, B, E, M, G, C, A, S, R, B, A, R, A. Consider any group. Consider this group also. Fluorine, chlorine, bromine, iodine, acetylene, hydrogen group. if you consider any group, then what happened? Atomic size increases from top to bottom. Next conclusion is decreases from left to right and increases from top to bottom in a group. So our conclusion is atomic size, that is radius, atomic size or radius decreases from left to right in a group. Sorry, this is not a group, this is left to right means this is period. Atomic size decreases left to right, atomic size decreases from left to right in a period and increases from top to bottom in a group. Final conclusion, listen carefully again. Atomic size gradually decreases from left to right in a period. Why? Due to increase in number of electron or increase in nuclear charge due to increase in force of attraction, that is nuclear force. Electrostatic force, it is also called van der Waals force. Then increases from top to bottom in a group, If you consider any group, there are 18 groups, if you consider any group, size increases from top to bottom in a group due to why? Due to addition of new cell. So important reason is left to right decreases due to increase in nuclear charge, nuclear force, and top to bottom it is increases due to addition of new cell. Okay, fine. Any doubt? Next class again we will read about how this is atomic size. Next class we read about ionic size, electron gain enthalpy and electronegativity. Okay, good. Thank you.